Okay, we're going to continue on with number 9. So I went ahead and took the liberty of just redrawing the picture, so that way I can just write in the picture to highlight certain parts. So first of all, looking at this right here, we know that line LM is parallel to PQ. So knowing that those are parallel will help me in finding some of these angle measures. So I'm going to go ahead and start off with finding the measurement of angle NQP. NQP. So if I highlight that, here's N, here's Q, and here's P. So we're looking at this corner angle right here. Now, if I take a look at this angle and extend it up to the top, you'll notice that this is a parallel line to here, and these corner angles are alternate interior angles. They should equal. This is 53 degrees. Let's go ahead and take a look at the next angle, the measurement of angle QPN. So let's trace that out. Q, P, and N is right here. So we're talking about this corner angle here. Now if you again extend it all the way to the top, here with the parallel line, we have alternate interior angles, and that corner angle will be 45 degrees. 45 degrees. That might be one of our special triangles later. All right, and then let's go ahead and take a look at this last angle, the measurement of angle PNQ. And if I trace P to N and then down to Q right here, I notice that it's this top angle right here. And I already have two angles of this bottom, and notice that makes a full triangle. So if I go ahead and take all three angles of a triangle, which add up to 180, and subtract out 45 plus 53, which is 98, and subtract, I get a total of 82. So that's 82 degrees here for that last angle. All right, now we're going to find side lengths. Now, side lengths, let's go ahead and start with the first one, which is QN. And we want to know what is the length from Q to N right here. Q to N right here. Okay, so let's see. There's a couple of ways you could do this. One is to look at, there's a little right triangle right here, and since I know this side is 18, you can use trigonometry to solve for a missing side length. This is the adjacent, and this is the hypotenuse, so I can use cosine to solve for it. Another way I can do this is I notice that there's a small triangle up here and a small triangle here. I'll cover the other parts. If you see those two triangles right there, those two triangles are similar triangles because this is 90 degrees, this is 90, and these are vertical angles right here and right here. So since these are vertical angles, I can use similar triangles and set up a portion, since I know 20 will coincide with the hypotenuse here is x, and I can use 12 with 18. So you have a choice. You can use trig or you can use your similar triangles. I'm going to go ahead and use similar triangles here just because later on we are going to use some trig later. So to solve for QN, I'm going to scoot this up. I'm going to go ahead and set up a proportion. So QN is what I'm solving for. So that's x over, and then this side right here is 20, with the other triangle covering that up, equals, and then 18 over 12. All right, I'm going to go ahead and cross multiply. So x times 12 is 12x, which equals 20 times 18, 360. If I divide both sides by 12, I get 30. So QN is a length of 30. If you did want to use cosine, I'll show you the setup of that. So this is the adjacent side, and you're trying to find the hypotenuse. So you could say cosine of 53 degrees equals adjacent, which is 18, over hypotenuse, which you're trying to find. If you cross multiply here, you get cosine of 53 times x, and that equals 1 times 18. Divide both sides by cosine of 53. And x is going to equal, and then you could put that into the calculator, as 18 divided by cosine of 53. And that gets you about 30 as well. So that gets in a more of an approximation of 30. So which is more accurate? Obviously this one is going to be more accurate, okay? Because cosine will get you an approximation. All right, so that's Qn. Let's go ahead and go to the next value that we have to solve for, which is PQ. So PQ is looking at this full length across the bottom here, P all the way to Q. Well, I have part of it, that's 18. So if I can find PR, I am good. Now I notice I had a 45 triangle here. So this is one of my special triangles, 45, 45, 90. And if this is 24 root 2, the side lengths must be 24. And I'll go ahead and write 24 right there as well. So P to Q is 24 plus 18. So 24 plus 18 gets you a total of 42. So 42 is the length from P to Q. All right, and then the last thing I have to find is NM. All right, NM, that's this side right here. N to M. All right, so looking at this, I do see another 45 there, so that might mean I have to use a 45-45 triangle. Now I notice this whole length right here is 28. So if I take 28 and subtract out the 12, that's going to get me this length, which is 16. So 28 minus 12 is 16. And since it's 45, this is 16, this is 16, this is 16 root 2. All right. I don't know why this is not focusing very well. Okay. So now let's go ahead and take a look at this next problem. We're going to find the length of the leg of the right triangle here. So if I want to find the length of the, let me try to zoom in here a little bit. I might have been really far because that last problem was pretty far away. All right, let's see. Ooh, that's really close. Let me scoot that back just a bit more. Okay, let's try that. Okay, here we go. To find the length of this leg right here, you notice you have two sides of the triangle. So if you have two sides of the triangle, then you could find the third side by just using the Pythagorean theorem. So for number 10, and you know you don't have a 45 or a 30-degree angles in there, so it's not a special triangle. This is just using the Pythagorean theorem. So I have a squared plus 21 squared equals 27 squared. Now I wonder if this is one of the Pythagorean triples. You could see if that would work. So the only reason why I went straight to this is it says leave the answer in simplified radical form. So it might not be a perfect triple. All right, let's go ahead and solve. So we have a squared plus, and then 21 squared is 441. And then 27 squared is 729. So if I subtract the 441 to the other side, I get 288. To get rid of the square, I'm going to take the square root of both sides. And if you try to take the square root of 288, you get a decimal. So we don't want to write a decimal because this is asking us to write a simplified radical form. So I'm going to instead break this down. Now I know it's even, so I know 2 is going to go in there, and that goes in there 144 times. 144 I know is 12 times 12. So that's my pair, and the 2 is left over. So A is going to equal 12 root 2. All right, let's go ahead and go on to number 11. Let me kind of see if I can fit this on this corner here. So number 11 says the sides of a right triangle are x plus 21, and x plus 24 units long. Find the side lengths of the triangle by solving for x. So on this case right here, again, we have a right triangle, so we can use the Pythagorean theorem. Now, I know that the hypotenuse is the longest side. So if this is x, and then this is 21 more than that, and this is 24 more than that, that will be the c value. So I'm going to go ahead and start with x squared plus x plus 21 squared equals x plus 24 squared. Now keep in mind we're going to have to multiply this out and make it all equal 0 before I can actually solve. So let's start with x squared plus, and now I'm going to FOIL this out. If you don't remember the shortcut for squaring, go ahead and write this twice and then multiply x times x and do that, or the box method. But I'm going to use the shortcut. X times x, x squared. X times 21 is 21x, and you double it, which makes 42x. And then 21 times 21 is 441 equals, and I'm going to use a shortcut here, x times x, x squared. 24 times x is 24x doubled is 48x. And then 24 squared is 576. 576. I don't know if you can see that. Okay, let's go ahead and add like terms. So x plus x squared, or x squared plus x squared is 2x squared. And then I'm just going to rewrite this other side. All right, I need to move it all to one side of the equal sign. So I'm going to go ahead and move all of these values to the other side. So I'm subtracting each one of these values. That will cancel all these out, and it will equal 0, so we can actually solve. 2x squared minus x squared is x squared. 42 minus 48 is negative 6x. And 576 minus 441 is 135. I should say negative 135. Okay, so anytime you have an x squared, that means you're probably going to have to do some factoring. Now, I know that I'm going to have to think of some numbers that multiply to get 135. So that's kind of a big number, but it does end with 5. So I'm just going to kind of see what sets of numbers multiply to get 135. So I know 5 goes in there. 135 divided by 5 is 27. Now 27 and 5 won't get me a 6. So let's go ahead and try 10, 15. So let's see, 135 divided by 15, that's 9. And 15 and 9 will work to get us a negative 6. We just have to put the negative in the right spot. So we have 15 and 9. And since this is a negative 6, 15 is going to have to be negative, while 9 is going to be positive. All right, let's split these up and make them equal 0. So we have x minus 15 equals 0, x plus 9 equals 0. So we have x equals 15 and x equals negative 9. Now, in context of this, we're talking about the side lengths of a triangle. And since x is a side length of a triangle, you can't have a negative side length. So negative 9 is out of it. So the only value that works is 15. So we have 15 units for the side length. Okay. All right, let's go ahead and take a look at number 12. All right, number 12, we have to find w, x, and y, and we're going to leave these in simplified radical form. So let me go ahead and redraw this. It kind of helps for me to be able to write onto the picture. So bear with me here. You know, these are equal. This is my W, this is my X, and then Y is down here. And we know this is 30 degrees and this is 36. So 36 is obviously the only side that I know. But I notice that there is a 30 degrees there. And if there's 30 degrees there, then I know that I can figure out the other sides using my special triangles. So this is a 30, 60, 90 triangle here. So if I have the hypotenuse, that's going to be my n side, or 2n side. The side that's longer is my n root 3. And then my value across from 30 is my n. Okay, so knowing that, I'm going to go ahead and use the fact that I know 36 is 2n. So 2n equals 36. Dividing by 2 gets me n equals 18. So since n is 18 and n is this short side, this is 18 right here, which is not one of the sides I need, but I do need this side. And since n is 18, this is 18 root 3. So I know y equals 18 root 3. That's one of the answers. All right, let's go ahead and solve for the rest of it. Now, I do notice that I have congruent sides here. So this is an isosceles right triangle, which means that this is also a 45-45 triangle. And a 45-45 triangle, the two legs are the same. So this is n, n, and the hypotenuse is n root 2. Since I know n is 18, this side must be 18. So I know x now. And since n is 18, this side is 18 root 2. So that's my W side. Okay. All right, let's go ahead and take a look at this next one. All right, we have a little chart that's going to help you organize all the information that you do know. So let me go ahead and start off by drawing this triangle out. So this is number 13. And I know this is 32, this is 29. Let me go ahead and write my chart. I need to find A, B, C, and these are capital A, B, C, and then lowercase a, B, and C. Keeping in mind that a capital letter denotes an angle measure, and these lowercase letters denote a side length. And the sides are right across from their angles. So let's start off with what we know. We know for sure that angle C is 90 degrees, so I can fill that in. This right here is across from angle C, so this is side C, that's 32. We know that this is 29, which is across from angle B, so this is lowercase b because it's a side length. So really I'm solving for 3 more things. I need angle A, angle B, and side A. Now, if I look at this triangle here, I happen to know 2 sides of the triangle. So I actually can find that third side by just using the Pythagorean theorem. So the Pythagorean theorem is a squared, which I'm solving for here, plus b squared equals 32 squared. All right, let's go ahead and find out what this is. So 29 squared is 841, and 32 squared is 1024. And if I subtract the 841 to the other side, I get 183. Taking the square root of 183, it wants us to round all angles to 1 decimal place and leave the sides in simplest radical form. Well, 183, let's see, 3 goes in there, a total of 61, and 61 doesn't break down. There's no pairs. So A is just exactly the square root of 183. I can't simplify it. So that's square root of 183. Okay, now we're going to go ahead and solve for angle measures. And so you can use the 2 sides that are known here and set up a trigonometric ratio. So let's go ahead and see what is in this picture here. I can use angle A or angle B. It's up to you what you want to solve for first. Since I want to solve for angle A, I'm going to go ahead and set up the ratio with this as my angle. So if this is angle A, this side right here would be the adjacent side. This side would be the hypotenuse. So let's go ahead and set up the ratio. Which one uses adjacent and hypotenuse? That would be cosine. All right, cosine of angle A equals adjacent 29 over hypotenuse 32. All right, we have to make this cosine go away. And the only way you can make cosine go away is by using the inverse. You use the inverse when you're solving for an angle measure. So A equals cosine inverse of 29 over 32. So go ahead and put that in your calculator. So basically you're going to go ahead and put second cosine and then 29 divided by 32. And that's going to get you a total of 25. Let's see, round all angles to one decimal place. Well, that angle is going to be 25.0. So angle A is about 25.0, one decimal place, degrees. So 25.0. Now, to solve for angle B, I really don't have to go through and do another trig. If I know angle A is about 25, I know all three angles of a triangle add up to 180. So to find angle B, I'm just going to have to take 180 and subtract what 90 and 25 is, which is 115. And 180 minus the 115 gets you a total of 65 degrees. So angle B equals 65 degrees. All right, so let's go ahead and go down to number 14. So number 14 is using your knowledge of special right triangles to evaluate all of these trig functions without a calculator. It says draw your special triangles to first help you out. So let's go ahead and do that. Let's draw our special triangles. Okay, so let's go ahead and put in 45, 45, 90. And then the other special triangle is the 30, 60, 90. All right, I'm going to go ahead and put in my side lengths. And if you remember for the ones that are in 45, 45 degrees, that will be n root 2. Some of your teachers used x maybe, x root 2. I like n because a lot of times it's solving for x and I don't like to mix the numbers. Oh, there goes the light. There we go again. Okay. And then this side is n, 2n, and n root 3. Again, you could have used x, 2x, and x root 3. All right, let's go ahead and do these starting with A, cosine of 45 degrees. I'll go ahead and write SOHCAHTOA here just so we can reference it. Okay, so looking at 45 degrees. All right, so I can use either one of these because if you notice, opposite and adjacent is the same no matter which angle you use as your reference angle. So I'm going to use this 45. So remember that for our cosine, it's A over H. So adjacent is N over H, which is N root 2. Well, I have N's that can cancel. So it's not just root 2 because root 2 is in the denominator, so it's really 1 divided by root 2. But you can't have a radical in the denominator, so we're going to have to rationalize this and multiply by root 2 on top and bottom. So that's going to get me root 2 over square root 2 times square root 2 is 2. So that's cosine of 45 degrees. All right, let's go ahead and do b. b is cosine of 60 degrees. So now our reference angle is 60 over here. Again, cosine is adjacent over hypotenuse. So if we look at this 60 degrees as our reference angle, this is the reference angles, what's adjacent to 60? N over hypotenuse 2n. Oh, I noticed that my n's again will cancel here, keeping in mind that 2 is in the denominator, so that's 1/2. All right, let's go ahead and do sine of 60 degrees. So we're using the same reference angle of 60, but this time sine is opposite over hypotenuse. So what's opposite of 60? Let's go all the way across in root 3 over the hypotenuse, which is 2n. And the n's cancel, and we're left with root 3 over 2. And then the last one, oops, I guess you couldn't see that, huh? There we go. So we had the n root 3 as our opposite of 60 over 2n, which is the hypotenuse, and the n's canceled, which got us root 3 over 2. And then the last one is asking for sine of 45 degrees. All right, so remember that sine is opposite over hypotenuse, and it doesn't matter which of these two reference angles you use. So let's say I use this 45. So I want opposite, which is n. Either way, opposite or opposite. And then the hypotenuse is n root 2. So my n's cancel. This gets me 1 over root 2, but again, you can't have a radical on the denominator, so I'm going to rationalize the denominator by multiplying by root 2, and that gets you 1 times root 2, which is root 2, over root 2 times root 2, which is 2. All right, and we'll continue on the back side.